All right, hello everyone. Today we are at last talking about the unit circle. We've sort of been leading up to this for a little bit now. Before we get started, just a few things you may want as you take notes along with this video is maybe three different colored pens or pencils, or maybe even highlighters, as well as a straight edge, and perhaps something circular to trace. So maybe something a little larger like a bowl or a large water bottle, something along those lines, something that still fits in your notes, but will give you a nice big circle because we will be drawing at least one of those today in our notes. Okay, so we're going to take a little moment here to do a warm-up where we are hopefully recalling our special right triangles. So remember our special right triangles, those are our 30, 60, 90, and 45, 45, 90 triangles. Now, when we looked at these last week or the week before, we sort of artificially almost set their hypotenuses, that's the plural of hypotenuse, equal to 1. I'm going to do that again. So I'm going to start with the triangle on the left. I'm going to say this hypotenuse, again, across from the triangle, or across the triangle from the 90-degree angle, is 1. Now notice I have my 90-degree angle marked and this 45-degree angle marked, but that of course means the other angle has to be 45, just as a little refresher. All three of the angles in our triangle always add up to 180 degrees. So if I was maybe solving for this other angle down here, let's say it's like x, I would write that 180 degrees is equal to 90 plus 45 plus x. Anytime we have those two angles, we're always going to find that the missing one is 45. So that's how I know this is in fact a 45, 90 triangle. Now if our hypotenuse is equal to 1, as we talked about in our lesson a few days ago, the two legs, they are equal, and they are equal to the square root of 2 over 2. This is definitely something we want to have committed to memory. So in our 30, 60, 90 triangle, again, I call it a 30, 60, 90 triangle even though I only have the 90-degree angle and 60 given. But of course, using that same idea, we're going to know that this angle that's missing is always going to be 30 degrees. Okay, so in this triangle, again, we're going to set our hypotenuse equal to 1 across from the 30-degree angle, across the triangle from that 30-degree angle. We're going to have the measure of 1/2, whereas across the triangle from our 60-degree angle will be equal to the square root of 3 over 2. Now these two triangles are going to come up again and again when we talk about our unit circle. So that's why we start off with just a little refresher. Okay, so let's define the unit circle. The unit circle is going to be some circle that is centered right on our origin, again the point 0, 0. It has a radius of 1 unit. That's why we call it the unit circle. So you can see we've got an example of the unit circle drawn. You may want to pause this video and draw one yourself. I recommend drawing the circle first, probably by tracing if you want it to be nice and truly circular, and then drawing in your axes as centered as possible. You can see that our unit circle intersects our x and our y axis each twice. And I've already labeled our degree measures of those 2 points, as we've been doing for a while now. So we can see that this point over here is 0 degrees, but also 360 degrees. Up here we've got 90 degrees, 180, and 270 degrees. These are our first 4 important points on our unit circle. And we want to now identify the coordinates of these points. So here's an important fact that you may want to add into your notes in addition to the definition of what our unit circle is. So the radius of our circle is always constant. I can draw any radius extending out from the center of my circle until it touches the circle itself, and that is always going to be equal to 1, no matter where it's drawn. So all of those are equal to 1. That means I can use my radius to determine the coordinates. So for example, if we look at 0 degrees, the coordinates of that point that represents 0 degrees, well, I went over 1, positive 1, so that would be an x coordinate of 1, and I didn't go up or down any, so my y coordinate is just 0. So 1, 0 is the coordinate of 0 degrees on the unit circle. Okay, if we look at 90, well, I'm not going up or down or left or right or anything from the origin. I guess I should say I'm not going left or right. I am going up, but I'm not going left or right, so my x coordinate 0. Whereas my y coordinate, well, it's the radius again, so it is just equal to positive 1. Over at 180 degrees, same idea, but this time my radius, it's 1 unit, but the coordinate is now negative 1 because I'm in negative x value territory now. So my coordinate here will be negative 1. My y coordinate is 0. And then down at 270 degrees, I still have not gone left or right in any direction, but now I have gone down 1 unit. So negative 1 is my y coordinate. So again, those are my first sort of 4 important points on my unit circle. Now let's talk about what else in general we need to be able to label on our unit circle, and also what these coordinates mean. Okay, so these are all kind of the coordinates that we generally label. We just did these 0, 1, 1, 0, negative 1. Oops, what have I done? Did I mix something up? Yes, I got these guys mixed up, didn't I? Let's fix that. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay. Now all of these other coordinates representing 30 degrees, 45 degrees, 60 degrees, 120, blah, 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 those are what we generally are finding when we're labeling the unit circle. So in order to determine those coordinates, I want to have us remember when we were talking about reference triangles. When we were given some point, we were told that the terminal side of our angle went through some xy coordinate. So I'm just going to pick a point here. Let's just say it's our 45 degree angle there. Let's say I don't necessarily know the x and y coordinate. Let's just say it's x and y, just generic. If I drop down a vertical line here and then sort of complete my reference triangle is what I'm going to call this. Here's my 90 degree angle. The line I dropped down, it's perpendicular to the x-axis. And then this here would be my reference angle. And I actually know that my reference angle is 45 degrees because I picked this particular point that corresponds to 45 degrees. Now I can label the sides on this reference triangle. It's the unit circle, so this hypotenuse that goes from the center out to the circle itself, it's equal to 1 unit. Now if the point is given by x and y, then this distance, my leg that's horizontal here, would be x, and my leg that is vertical here is going to be y. So I can do that for literally any point I pick anywhere really around my circle. So that also means, we looked at this as well last week, I could write for my reference angle, the sine of that angle, theta, is equal to y, because y is the opposite of my reference angle here, over r, or, well, okay, this is a unit circle, so r is specifically equal to 1, which also means then sine of theta is equal to y. We also might say, just like flip that around, y is equal to sine of theta. Interesting. I can write that the cosine of that angle, cosine of theta, is equal to x over, again, 1 on the unit circle, because 1 is always the hypotenuse. So cosine of theta is equal to x, or again, we could flip that around and say x is equal to the cosine of theta. Now, it's also, valuable to know that the tangent of theta would be equal to y over x, the opposite over the adjacent. Although we usually don't label the tangent of theta on our unit circle. We usually just use the sine and the cosine. So going back to kind of our coordinate point, let me see if I can clean this up a little bit. If I know that, again, my coordinate is just some x and some y, well, if it's on the unit circle, then I actually know that x is always going to be equal to the cosine of whatever the angle is, whatever my reference angle is, and y is always going to be equal to the sine of my reference angle. So in this way, we're going to be able to determine these coordinates of all of these different points using our special right triangles. So using, again, those triangles that we looked at sort of as a warm-up today. Memorizing these is really the bulk of the memorizing that you have to do when it comes to the unit circle. Knowing that if we're looking at a 45, 45, 90 triangle, that our sides are square root of 2 over 2 and 1. And if we're looking at a 30, 60, 90, then we have the side lengths of 1, 1/2, and root 3 over 2. That's really the most important thing to have memorized. And we're going to talk about how by focusing in on just the first quadrant of our unit circle. Like here. So I've sort of zoomed in a little bit. Now here's where having 3 different colors is going to come in handy. Because I'm going to draw 3 different reference triangles sort of superimposed on top of my unit circle. So maybe I'll pick this light green for my first one. So we're going to start with 30 degrees. What I'm trying to determine are, what are my x and y coordinates for 30 degrees? Remember, that's also answering then, what is the exact version of the cosine of theta and the exact version of sine of theta? X is equal to the cosine and y is equal to the sine. And I guess I don't even need to say theta, I can say 30 degrees here. Okay, so let's drop down our vertical line, and I'm just going to maybe go over this radius in my light green. It'd be nice if I had a straight edge I could use, and then go over the bottom x-axis in light green as well. Okay, so my right angle goes here between my x-axis and that vertical line I just drew, and now I've got my reference angle of 30 degrees. I know it's 30, again, just because this point on my unit circle corresponds to 30 degrees. Now, being the unit circle, I know my hypotenuse is again going to be equal to 1. Any point extending out from the origin to the edge of my circle will be equal to 1 here, which means I can fill out the remaining side lengths using my 30, 60, 90 triangle knowledge. So across from the 30 degree angle, well, that's going to measure 1/2. I haven't labeled it, but this angle in this corner is 60 degrees. Across from that angle is the square root of 3 over 2. Okay, so which is x and which is y? Well, x represents my horizontal distance, so x is equal to the square root of 3 over 2. That's also what the cosine of 30 is. And y is equal to 1/2. That's also the sine of 30 degrees. So I'm going to take away my little just x comma y, and I'm actually going to fill in square root of 3 over 2 and 1/2. Those are the coordinates on the unit circle corresponding to 30 degrees. Okay, let's move on to 45. Let's pick a new color. Maybe I'll use a bright blue. So same idea, I'm going to drop down a vertical line and go over my radius in blue and extend from along the x-axis as well. Okay, so it's a little busy. I might try to clean this up a little bit. I'm just going to remove that little 30-degree angle and these little arrows, and just so I have some space to work with. Okay, well, let's put that guy back. All right, so same idea. We know that this reference angle is 45 degrees and my hypotenuse is 1. So this being a 45, 45, I could fill in this other angle, 90 triangle, means I can fill out the sides as well. This side is going to be root 2 over 2, and this side is going to be root 2 over 2. All right, so my coordinates then are square root of 2 over 2, square root of 2 over 2. That also means that the cosine of 45 degrees is equal to square root of 2 over 2, and actually the sine is as well. They're equal in this case. Okay. So if I were to ask you, like, what is the cosine of 45 degrees, and you had perhaps a unit circle to look at, you could just go to, okay, what is the x-coordinate on the unit circle for 45 degrees? Oh, square root of 2 over 2. Voila. All right, let's talk then about 60 degrees. So again, I'm just going to clean up a little bit of this stuff so we have some space. And let's switch to maybe red so we can see it well. Okay, so I'm going to go over my radius. I'm going to drop down a vertical line and then just complete my triangle. That is a right angle between my x-axis and that vertical line. And my hypotenuse is yet again 1. So this time my reference angle is 60 degrees. The other angle in this corner of my triangle is 30. We have a 30, 60, 90 triangle. And we already did this before, but you can see that my triangle is oriented a little bit differently than the first 30, 60, 90 triangle I drew. Across from the 30-degree angle is now actually the x-axis, or the x-coordinate, I should say. That's 1/2. Across the triangle from my 60-degree angle, root 3 over 2, that's now my y-coordinate. That's my vertical distance up to this point. So then the coordinates of this point will be 1/2 square root of 3 over 2. Again, that tells us that, for example, the sine, if I'm looking at the y-coordinate, the sine of 60 degrees is equal to the square root of 3 over 2. Okay. Now, these are points that are kind of on the border of quadrant 1 that we already labeled but didn't necessarily go into too much detail on. Remember 0 degrees? We said that because it's on the edge of our circle, and we haven't gone up or down at all, the coordinates right at 0 degrees were just 1, 0. So this coordinate pair, this also satisfies the same idea where the cosine of our angle is equal to the x and the sine of our angle is equal to the y. So this actually tells me that the cosine of 0 degrees is actually equal to 1, while the sine of 0 degrees is equal to 0. You could confirm that on your calculator. This also means because 360 degrees is this same point, the cosine of 360 degrees is 1. The sine of 360 degrees is 1. What about up here at 90 degrees? Well, the coordinates were 0, 1. Okay, so our x, that corresponds again to the cosine. So the cosine of 90 is 0. The sine of 90 is equal to 1. Again, you can confirm that on your calculator. Okay, so that was just quadrant 1. The other 3 quadrants, though, are almost identical. There are some key things to note when we're drawing our reference triangles, but otherwise we're going to follow the exact same process. So I'm going to go to my next here. And what I want us to know about here in quadrant 2 is that we're still going to be using these reference angles and reference triangles. This time it's really important that we identify the reference angles of now 120 degrees, 135 degrees, and let's see, what was the other color I used? Red, 150 degrees. Okay, because we don't necessarily have memorized what is the sine of 150 degrees. Oh, but I can figure out the sine of 30 perhaps. The other important fact is here. In quadrant 2, all x values are negative. Remember, the x values also correspond to the cosine of whatever our angle is. So if we're just maybe like filling out our coordinate points, we know we're going to have a negative for all of our x's. We are still going to have a positive for all of our y's though. Our y coordinates are all going to be positive in this particular quadrant. So I want to pause here. There's a few steps there for you to follow. I want to give you a chance to sketch out your angles for 120, 135, and 150 degrees and determine those coordinates using, again, reference triangles. So I'm going to pause for a moment. You may want to pause the video, so I'll kind of pick back up here. Okay, hopefully at this time you've paused and come back. We're just going to basically check our work. So I'm going to start with 120 degrees. Let's see, I'll use red again. Okay, so if I sketch my reference triangle, I then need to determine what is this little angle here, my theta prime or my reference angle. Well, that's the difference between my angle, 120 degrees, and the x-axis, which is 180. The difference between those two numbers is going to be 60. So my reference angle here is actually 60 degrees, meaning up here we've got 30, and I didn't indicate it, but of course we've got our right angle there. So using that information, we can then say that our coordinates are negative 1/2 for x and positive √3/2 for y. Okay, for 135 degrees, we would again sketch our reference triangle. Here we are. Okay, so we know, of course, the hypotenuse is 1. I didn't label that on the last one. There it is. And in this case, this angle, my reference angle here, is going to be, again, the difference between 135 and 80. Well, that's just going to be 45. So we've got a 45 degree reference angle. There we go. I'm not sure why it didn't let me draw in there. Which means our coordinates are going to be negative √2/2, comma, positive √2/2. Again, negative because this x coordinate is into our negative x value territory. All right, last one here then. Let's switch back to green to keep consistent. We'll drop down our vertical line and finish our triangle. There we are, hypotenuse of 1. So what is the difference between 150 and 180? Well, that would be 30 degrees, so our reference angle here is going to be 30. Okay, so we've got another 30, 60, 90 triangle, and our coordinates, therefore, will be negative √3/2. There we go, and positive 1/2. So again, I could ask you something like, what is the cosine of 135 degrees? And let's say you had your unit circle to look at, or I was asking you to use your unit circle to do that. Well, you could then look at, okay, the x coordinate of 135 degrees, that's negative √2/2. That's the type of question will be asked relating to the unit circle. Okay. Now our quadrants 3 and 4, almost identical, but this time we have a sort of different note about the negative and positive of our x and y values. So think about it. In our third quadrant, are the x and y values negative or positive? They're actually both negative. So that means also both our sine and cosine values for any angles in that quadrant, they will be negative. Okay, in quadrant 4, our x, they actually go back to being positive. We're back into positive x value territory, which means our cosine values, they will be positive. Our y values, though, we're still in negative y value territory, so our sines of these angles will all be negative. So again, I would like you to pause and take this moment to practice identifying your reference angles and drawing your reference triangles to determine the coordinates. All right, so I am going to just basically be filling in the coordinates. Of course, if you've got questions about where these values are coming from, that's where you can always reach out to me. Okay, so here at 210 degrees, our reference angle would be 30 degrees. And using our 30, 60, 90 right triangle, we would say our coordinates are negative root 3 over 2, negative 1/2. For 225, we'd be looking at negative square root of 2 over 2, comma, negative square root of 2 over 2. Okay, for 240, our reference angle would be 60 degrees. So we'd be looking at negative 1/2, negative root 3 over 2. Okay, over here at 300, we'd be looking at positive 1/2. Again, positive x values over here. But negative root 3 over 2, negative y values here. For 315, positive square root of 2 over 2, but negative square root of 2 over 2 for the x, or excuse me, for the y, for the sine of 315 degrees. And then lastly, for 330 degrees, we'd be back at positive square root of 3 over 2 and negative 1/2. So again, I might ask you, for example, what's the sine of 300 degrees? The sine of 300 degrees would be the x-coordinate here corresponding to 300 degrees on the unit circle. So negative square root of 3 over 2. Okay, so you might also be wondering, like, how do we label our blank unit circle? Every once in a while you're asked to do that. If we don't, like, how do we know what the angle measures, essentially? So here are the angles in degrees. I just want to talk about the patterns we see here first. So for our degrees, of course, we'll always have these 4 intersections with our axes. So 0 degrees, also 360 over here, 90, 180, and 270. Then we have increments of 30. So if we go up 30, we get to 30 degrees, then to 60, then to 90, 120, 150, so on and so forth. So we have all increments of 30 all the way back up to 360 degrees. Now we also throw in, though, increments of 45. So we'll have up from 0, well, 45. Then next is 90, okay, 90 plus another 45 is 135, plus another gets us to 180, and so on and so forth. Okay, but our unit circle, as sort of a heads up, it also often requires us to utilize radians. This is just degrees. So while we could just convert our radian measure every time into degrees and just memorize the degrees, it's really handy to notice some patterns when we're looking at the radians as well. So of course, when we're looking at 0/360 degrees, that's still 0 radians, but then for 360, that's 2 pi radians. 360 is a full circle, 2 pi is also a full circle. 30 degrees will be pi over 6, or 1 pi over 6. I'm going to write everything as in terms of sixth here for the time being. In fact, maybe I'll kind of rearrange that. 1 pi over 6, which just simplifies to pi over 6. If we talk about 60 degrees, let's just do the intervals of 30 degrees for now. Well, 60 degrees is also 2 pi over 6, which simplifies to pi over 3. Okay, 90 degrees, we could say that that's 3 pi over 6, which simplifies to pi over 2. This one you may or may not have memorized at this point. Okay, anyone notice a pattern yet? If we look at 120 degrees, that's going to be 4 pi over 6, or 2 pi over 3. Next increment of 30 degrees, 150, that would be 5 pi over 6, which can't be simplified. Oh well. 180 would be 6 pi over 6, or just pi. 210, 7 pi over 6. I think we probably see where this is going. 8 pi over 6, which is the same thing as 4 pi over 3. 9 pi over 6, which is the same thing as 3 pi over 2. 10 pi over 6, which is the same thing as 5 pi over 3. And lastly, 11 pi over 6, which does not simplify. So our increments of 30 are also increments of 1/6 of pi, or increments of pi over 6. And then we can just simplify the fractions that are able to be simplified. So we skipped over those increments of 45 degrees. Well, 45 degrees, that's also, let's see, maybe I'll do dark blue here. That's also the same thing as pi over 4. Okay, the next increment of 45 degrees is technically 90. We already said that that's pi over 2. Well, that's also 2 pi over 4. Simplifies just the same. 135 degrees is 3 pi over 4. 180, technically the next increment of 45 degrees, is also, 4 pi over 4. So you can see our increments here are pi over 4, or fourths of pi. So here we'll be looking at 5 pi over 4. 270 is also 8, let's see, not 8, 6 pi over 4. And 315 is also 7 pi over 4. Okay, so that's one way we might be able to memorize kind of the patterns there of the angles that are used on our unit circle. This is all of them. There's not going to be some other random point given and you're going to have to determine that. No. You only will need to know, if you're specifically asked about the unit circle, these points, their radian and degree measure, like we've labeled here, and then also their coordinates. And of course, their coordinates are how we get their cosine and sine and their tangent values. Okay. So this is kind of the summary to a degree. This is sort of like the questions you might be asked. So in many classes, you're asked to fill out a blank unit circle, which means you'll have to label again the degrees of each point, the radians, and the coordinates. And with the unit circle, you want to be able then to determine what's the sine, the cosine, or the tangent of some angle in both degrees and radians. And you want to be able to go sort of backwards. If you're given the sine, the cosine, or the tangent value, then you want to be able to figure out what is the corresponding angle measure and also the coterminal angles. Okay, so that is the unit